Learning to engineer with Heaviside functions is really quite useful because it gives us a way to turn things on and off. And as we'll see, the Laplace transform of a Heaviside function actually leads us to working with purely continuous functions, which is kind of cool. But before we get there, let's engineer one more. In our previous example, we looked at having an output of 0 and then 1 and then 0. But suppose we want the function, instead of this signal just being a 0 or a 1, suppose we want to use the Heaviside to activate the function e to the negative 2t. But it start at time t equals 3, as it would normally start at time equals 0. So for a moment, let's consider what we mean by this, and let's go ahead and plot e to the negative 2t. So when t is 0, e to the 0 is going to give us an output of 1. Which is not, I'm not saying that because it has to do with the Heaviside, but this function does have that. And then what happens as time increases, this thing rapidly decays down to 0 like this. But what I would like instead is I would like where this graph begins at time 0, I want this to start at time 3. So imagine that what we do here is we're actually shifting this thing, we're shifting this point 3 units to the right, and that's where we want it to begin. So if this is e to the negative 2t, and what I want is e to the negative 2t shifted, we'll call this guy f of t, then what I actually is I want f of t minus 3. And what would that look like? Well, f of t minus 3, remember what that means is replace the input with t minus 3. Well, the input is e to the negative 2 times quantity t minus 3. And that would be exactly the shifted graph 3 units to the right of e to the negative 2t. Now, this is exactly what I want to see almost. Well, let me now draw our desired. So our desired graph would do this. And maybe this isn't explicitly stated in the problem, but here, this was my intent. Up until time 3, nothing happens. Up until time 3, nothing happens. That's what I want. Up until time 3, nothing. And then at time 3, I want this exponential function to activate. And then as time goes on, of course, we know that this thing decays. So the Heaviside function will go from 0 to 1. But the exponential function needs to go from 0 to this function e to the negative 2 times t minus 3. Okay, so in order to do this, one option that I have is, again, if I kind of set up a t-table for what I want, well, we know that u sub 2, or sorry, u sub 3, the reason I'm plotting u sub 3 is because I know I'm going to need to use that because at time 3 something happens. So up until time 3, we have the u sub 3 function would give me a 0, and then at time 3 would give me a 1 for all time afterwards. But I know that what I want is I want the function e to the negative 2 times t minus 3. Now this is going to give me some number, right? I'm just going to put number there. It's going to give me a number, and then it's going to give me the number that I want, right? Because if you think about what this function would look like for other values of t, this thing kind of shoots straight up, right? I don't want that piece. I want it to be 0 up until that time. So at this point, I actually want whatever the outputs of this guy are, which, you know, e to the 0 would be, it would give me a 1 right here, and then some other number. Now, in order for this number that I get, which will not be 0, these will be non-zero, in order for these to become zeros, I can think about how I can combine the u sub 3 function. Now, if I take the output of u sub 3 and I multiply it by e to the negative 2 times quantity t minus 3, I'm going to get a 0. So what happens when I multiply the Heaviside by the function? Okay, when I multiply, it's either going to be 0 times the function or 1 times the function. So this will give me 0. 0 times any number is 0. 0 times any number is 0. 0 times any number is 0. And now look what happens. 1 times whatever the output of this function is, which in this case it'll give me a 1. But in general, it'll give me, right, e to the negative 2 times 3 minus 3, which is 0. And then it'll give me e negative 2 to the 1 and e negative 2 to the times 2. And so now I'm actually going to be generating non-zero values. So the answer here is that in order to get 0 up until time 3, and then to start getting the values that the function that I'm interested in actually outputs, my function in this case would be, maybe I'm not going to use f of t. My answer would be that I want u sub 3 times e to the negative 2 times quantity t minus 3. And as a piecewise function, what this will give me is it will give me 0 before time 3. Right? It doesn't matter what the output of this is because this quantity right here will always be a 0 as long as time is less than 3. And then at time greater than or equal to 3, well, remember that this guy will become a 1, and it will be multiplying whatever the output of this exponentially decaying function is, and we'll just label that as e to the negative 2 times t minus 3. And this is a perfect way to switch on power sources in an electronic circuit, to turn things on and off that are not simply just zeros and ones. So if you want to turn on a function at some time, you can multiply the function by the corresponding Heaviside. Pretty cool stuff. Now, in what we're about to look at, we're going to need 2 Laplace transforms. And the first Laplace transforms is, of course, of the Heaviside. And what I want you to notice with this Heaviside is that even though the Heaviside is a discontinuous function, when we go from the t domain into the s domain, notice that we get a continuous function, right? By definition, the Laplace transform of a function of t is the integral from 0 to infinity of f of t times e to the negative st dt. And I just want to show you really briefly what this function will look like or why we get a continuous function out of something that is discontinuous. So if I take the Laplace of u sub a, remember u sub a will be 0 from time 0 up until time a. So the f of t value will be a 0 between time 0 and time a. Well, that's an easy integral to take. But then when we look at from time a to time infinity, it's going to be an output of 1. Well, what's the integral of 0? What's the area under the 0 curve? Well, this is just going to be 0. And this will be the integral of e to the negative st is negative 1 over s e to the negative st. And now evaluate it from t equals 0 to t equals a to t equals infinity. At infinity, this thing will equal 0, because e to the negative s times infinity is 0 for positive s's. And then if you plug in a, subtract away the function evaluated at the lower endpoint, you'll get negative 1 over s e to the negative s times a. And this is not, the e is not in the denominator here. So notice that is what we end up with, e to the negative as over s. We're going to need number 2 because, we're going to be turning functions on and off. And if you notice what's going on here is we have the product of a Heaviside and some shifted function. So that's the key here. If at time a we're going to activate the function, we need the function to be shifted over a units from its starting point. So kind of like we saw here, right? This got shifted over a units, and then we multiplied it by, or 3 units, and we multiplied it by the Heaviside to activate it at time 3. And that's going to be helpful, and we'll take a look at a couple of examples with this in the next video.